Hi all, in this example, I'm going a little out of order from what they are in the packets, but I like this one after our equations. In this example, we're going to work at taking apart compositions. So knowing some possible functions that we might have started with, can we look at a composite function and figure out how we got it? We have function m here, which is a linear function. So m of y is just equal to y minus 1. Function n of y is a reciprocal function. Whatever you give it, it will give you back 2 divided by your input. And function p, whatever you give it, it will cube it. So we have a function that subtracts 1 from inputs, that puts inputs on the bottom of this fraction with a numerator of 2, and one that cubes inputs. So again, our goal, this is kind of like a transformation problem from earlier, is to look at function a and say, how did I get function a if my only option was to compose m, n, and or p in whatever order needed? And you can compose functions with themselves. So if I look back up at functions m, n, and p, I'm seeing y's in the denominator and 2's in the numerator, which makes me think n should be part of the mix. So I'm thinking I want an n. I'm also seeing a minus 1, which makes me think I want an m in the mix. So basically now, if we've guessed correctly, we're trying to decide between n of m of y and m of n of y. Okay, and you can just check these. If you can see it, great. If not, go for it. So m of y is a y minus 1. If I plug a y minus 1 into function n, it will give me back 2 divided by y minus 1. This looks great, so I think that's my answer. This function is equal to n of m of y. And that's what I want, just the function notation to tell me if you plug m of y into n, you'll get function a. Just so that we can see what happens if we try it the other way. Let's see, n of y. Okay, so this is a 2 over y. If we then plug that back into m takes whatever we give it and subtracts 1. So this would give us a 2 over y minus 1, which is not what we wanted. Okay, so as soon as you start feeling like you've got the idea of this, I would pause and see if you can figure out the rest of these and then double check by running through the video. So I'll keep going, but that's a great idea. B of y, I supposedly composed functions and ended up with y minus 2. So I definitely have a y minus 1 function. None of these other functions would make me subtract anything more, so I'm really only seeing m of y as a good option here. If I want to subtract 2 from a y value, I basically need to apply m of y twice. So I'm predicting that it's an m of y. If I want m of y, I first plug in my y, I get a y minus 1. I then plug that back into m. M takes whatever I give it and subtracts 1. And there is my y minus 2. So m of m. Okay, C. C has a y in the denominator, so I'm thinking I want to use an n to get that y in the bottom. And it also has a cube, so I'm thinking I want to use a p. So again, this can just come down to a little bit of trial and error. Do you want n of p or p of n? Okay, so if I take n of p, that means I'm taking n of y cubed, which is going to give me a 2 over y cubed. N takes whatever I give it and puts it in the bottom of a fraction whose numerator is 1. That's not looking quite right, so hopefully p of n will work. P of n of y. This is saying to plug 2 over y into function p. Function p takes whatever I give it and cubes it. That will, in fact, give me 8y cubed. So that's looking perfect. P of n of y. Pony. Okay. Let's see, D. D wants me to get a y cubed minus 1. So I'm seeing the cube, which means I'll want function p. And I'm seeing minus 1, which means I'll want function m. So I want to think about p of m of y, oops, versus m of p of y. Okay, so if I first take function m of y, that's a y minus 1. If I plug that into p, I'm going to get y minus 1 cubed. Not quite what I'm looking for. Instead, I can try plugging y into the p first. I get back a y cubed. If I then plug that into m subtracts 1, that's what I'm looking for. So m of p of y gives me d of y. E of y equals y. Okay, so I want to basically put two functions together and end up with just the variable I started with. So I need these functions to sort of undo each other's operations. I think this one can be a little tricky, so absolutely you can just start plugging functions into each other and see what happens. The one that looks like a good candidate to me is the n of y, and actually just the n of y, because the reciprocal of a reciprocal gets you back where you started. If you take 1 over y and then you take 1 over that, you get back to y. We have a 2 over y, but we can double check ourselves and make sure this is working. So if we want an n of y, we get an n of 2 over y, which is a 2 over y. To calculate 2 divided by 2 over y, you would multiply by the reciprocal. Notice that puts the y in the top and cancels out the 2's. So that is, in fact, an n of y. Okay, we're getting close because we're going to start running into some that I think we've already figured out. F of y equals y to the 9th. I don't think we figured that one out. We have a cube function. We're trying to get a 9th power. So I'm thinking that if we just cube the cube function, we'll be in pretty good shape, which means p of y. So we want p of y cubed, which is y cubed cubed. Sometimes people get a little thrown off and try and claim this is a y to the 27th. Remember, the rule is if you raise something with a power to a power, you multiply exponents. So it's actually y to the 9th. So that is a p of p. Okay, last three, I think we already have these if we just go back and look at some of the trial and error we did. G of y is 2 over y cubed. That's this one right here. So this is an n of p of y. H of y is 1 minus y cubed, is that one, which is a p of m of y. And I of y equals 2y minus 1 is an m of n of y. All right, so we want to be able to go both directions. We want to be able to, given equations, compose them and find the new composite function. We also want to be able to work backwards, given the composition, figure out how we got it, what original functions you could put together to get that. All right, thanks for watching.